on pages 13, 26, and 27, we were introduced to exponential notation, where the exponents would be integers. In other words, 0, 1, 2, 3, and the opposite, -1, -2, -3, etc. In this section 6.2, we're talking about rational numbers as exponents. And so to begin with, we define what a to the 1 divided by n means. So we have actually 4 objectives here in section 6.2. To write expressions with or without rational exponents and simplify if possible. To write expressions without negative exponents and simplify if possible. And then use the law of exponents with rational exponents. And then we use rational exponents to simplify radical expressions. So to begin with, we look at the definition of a to the 1 over n. And so what it means is for any non-negative real number a and any natural number index n not equal to 1, a to the 1 divided by n means the nth root of a, the non-negative nth root of a, that is. So to begin with, we're going to look at some exercises here. They're very simple. Rewrite without rational exponents and simplify if possible. So based on the rule that we just discussed a moment ago, this simply means it's the 4th root of y. And this would be the square root of 3a. Now notice when it's the square root, we don't write the index of 2. Because it's assumed that if there's no index, it is implied to be the index of 2, the square root, that is. Now number 3, that looks a little different, 16 to the 1/4 power. Now realize we can write 16 as, or 16 to the 1/4 power. We can write 16 as 2 to the 4th power. To the 1/4. And so from the rule of raising a power to a power, that's 2 to the 4 times 1/4, and that's equal to 2 to the 1st power, or simply equal to 2. So that equals 2. Similarly, we can write 125 for number 4. We can write 125 as 5 to the 3rd power to the 1/3 power. So that's equal to 5 to the 3 times 1/3, which is 5 to the 1 power, or simply 5. So that's equal to 5. And number 5 is the 5th root of a to the 3rd, b to the 2nd, c. So based on the definition of what a to the 1 over n means, this is then equal to 19 ab to the 1/3 power. Now this one is equal to 19 times, remember that ab is a radicand here, so it's 19 ab to the 1/3 power. So In the previous example, 19 was part of the radicand, and in number 7 it is not. That's why it's 19, why 19 is not raised to the 1/3 power. So here we have the radicand, x squared y divided by 16. And note we need to enclose this whole expression in parentheses and raise it to the 1/5 power, because 5 is the index here. Similarly, number 9, the radicand is 2ab, so we have 7 times 2ab to the 1/4 power. Now comes a very important definition, and that is what a to the m divided by n means. This is really important, and you definitely want to memorize this. So, for any natural numbers m and n not equal to 1, and any non-negative real number a to the m divided by n means the nth root of a to the m, or the nth root of a raised to the mth power. So these two expressions are identical, they're equivalent for sure, they're identical actually. And it turns out that in general, when you have to evaluate an actual expression like this is typically the easier one to evaluate. You know, think about it, the nth root of a is typically easier to evaluate than the nth root of a to the m. So once we evaluate the nth root of a, we raise that answer to the mth power, which is, again, typically easier to do. But anyway, the main thing is to realize what a to the m divided by n means. So let's do the following exercises. Number 10, x to the 3/5. That means it is the 5th root of x to the 3rd. Remember that the denominator in this rational exponent is the index. So the index is 5 and the power is 3. So similarly, this means the 3rd root of 8 to the 2nd power. And again, realizing the equivalence we just discussed, that's also the same as the 3rd root of 8 rather, raised to the 2nd power. That was the second definition of a to the m divided by n. Now we know that the 3rd root of 8 is 2, so we need to raise 2 to the 2nd power, and that's equal to 4. So the answer is 4. So the 3rd root of 8 is 2, and 2 to the 2nd power is 4. And this expression means, since the index is 2, the square root of 4 to the 5th power. And again, that's easier to do as the square root of 4 raised to the 5th power. And the square root of 4 is 2, and 2 to the 5th power is equal to 32. Of course, you could raise 4 to the 5th power and then take the square root, but again, that's a little bit more involved, and so, as I mentioned before, it's typically easier to use this way to evaluate this kind of an expression, or it's in number 11. So in number 13 and 14, we're asked to do the opposite. So here, the index 3 becomes the denominator of the expression 7, a, b, c, the radicand, to the 4th divided by 3 power. Or to the 4/3 power. Similarly, here we can write this expression as 6 to the 7/5. Next we have negative rational exponents, a to the minus m divided by n. And so for any rational number m divided by n and any positive real number a to the minus m over n means 1 divided by a to the m divided by n. In other words, a to the m divided by n and a to the minus m divided by n are reciprocals, meaning the product is equal to 1. So let's look at number 15 and 16. So 16 to the minus 1/4 means 1 divided by 16 to the 1/4 power, or 1 divided by the 4th root of 16. And that's equal to 1 divided by the 4th root of 2 to the 4th. And so the 4th root of 2 to the 4th is 2, so 1 divided by 2, or 1/2. That's equal to 1/2. And similarly, number 16 is then equal to 1 divided by 3x y to the 7/8. And that's as far as it goes. So it's equal to 1 divided by 3x y to the 7/8 power. So next, number 17 is a guided solution. So 81 to the minus 3/4 means 1 divided by a to the 3/4 power, or the 4th root of 81 raised to the 3rd power. And since the 4th root of 81 is equal to 3, it's 3 to the 3rd power, and that is equal to 27. So the answer is 1/27. Similarly, rewriting number 18. So notice that this is a product of 7p to the 3/4 times q to the minus 6/5. So in other words, that's 7 times p to the 3/4 power divided by q to the 6/5 power. In other words, this part now goes in the denominator with a positive exponent. So that's the answer to number 18. And the answer to number 19, there's a special rule, and that's, let me just write this over here, what the rule is, that m divided by n to the minus r power is equal to n divided by m to the r power. So in other words, when we take the reciprocal of the expression in parentheses, then it becomes a positive exponent. So in other words, that's equal to 7n divided by 11m to the 2/3 power. So we interchanged the numerator and denominator, and that then made it a positive exponent. So this is a very useful rule to know. So here's a review of the laws of exponents. And the basic part is that the same laws hold for rational number exponents as for integer exponents. And so here they are, a to the m times a to the n is equal to a to the m plus n. That's a product rule for exponents. So in multiplying, we add the exponents if the bases are the same. So pay attention that the bases have to be the same. Similarly, the quotient rule says a to the m divided by a to the n is equal to a to the m minus n. So in dividing, we subtract the exponents if the bases are the same. Number 3, to raise a power to a power, a to the m raised to the nth power is a to the m times n. In other words, we multiply the exponents. And then raising a product to a power, ab to the m, means we raise each factor to the mth power, a to the m times b to the m. And when we raise a quotient to a power, we raise both the numerator and the denominator to that power. So that's a to the n and b to the n, divided by b to the n. So these 5 rules is what's expected that you remember them, because we will be using them throughout the rest of this chapter. So what this means, 7 to the third times 7 to the 3/5, we're using the product rule. It means 7 to the 1/3 plus 3/5. So the LCD for these two fractions is 15. So we need to multiply the first fraction by 5 divided by 5. So it becomes 7 to the 5 divided by 15. And the second fraction we multiply by 3, so it becomes 9 divided by 15. So now we have the same denominator, and 5 plus 9 is 14. So it's 7 to the 14 divided by 15th power. Similarly, when we have a quotient, remember we subtract the exponent, so that becomes 5 to the 7/6 minus 5/6. And that means 5 to the 7 minus 5 is 2, 6. Or reducing the exponent, the fraction in the exponent, 5 to the 1/3 power. And in number 22, we're using the power to a power rule. So that becomes 9 to the 3/5 times 2/3. So the 3's cancel. So that'll be then 9 to the 2/5 power. For number 23, the power to a product of a product rule applies. So we raise each factor, p to the minus 2/3, and the other factor is q to the 1/4 to the 1/2 power. So now that's going to look like this. P to the minus 2/3 raised to the 1/2 power times q to the 1/4 raised to the 1/2 power. So now we need to apply the raising a power to a power. So we have p to the minus 2/3 times 1/2 times q to the 1/4 times 1/2. So here the 2's cancel, and it gives us a p to the minus 1/3 times q to the 1/8 power. Now remember, this now is a negative exponent, so that means 1 divided by p to the 1/3 times q to the 1/8, and we can write that as q to the 1/8 power divided by p to the 1/3 power. And now we're going to talk about simplifying radical expressions. And there are 3 steps typically. And that is to convert radical expressions to exponential expressions, and then use arithmetic and the law of exponents to simplify, and then convert back to radical notation when appropriate. So let's do a couple of examples. Now here's an important observation. The procedure works only when we assume that a negative number has not been raised to an even power in the radicand. Okay, so remember that part. Okay. And so with this assumption, we don't need the absolute value signs. So here the question is use rational exponents to simplify. And so it means the fourth root of a squared. That means a to the second divided by 4, or a to the 1/2. And a to the 1/2, of course, is the square root of a. So this is equivalent to the square root of a. And we know that the fourth root of x to the fourth is equal to x. And because of what was said here, this procedure works only if we assume that a negative number has not been raised to an even power in the radicand, so we don't need absolute value signs. Remember, this is an even root, so ordinarily would need absolute value signs, but because of this assumption here, we don't need absolute value signs. So for number 26, the sixth root of 8, we can write 8 as 2 to the third. So this expression then becomes 2 to the third divided by 6. Remember, the index becomes the denominator in the rational expression, the rational exponent. And of course, 3/6 is the same as 1/2, so it's 2 to the 1/2, and that's equal to the square root of 2. So this is equal to the square root of 2. So for number 12, we can rewrite this as x to the third, y to the sixth, to the 1/12th power. So that means it's x to the third times 1/12th, y to the sixth times 1/12th, multiplication symbol here. So that's x to the 3/12th power, and times y to the 6/12th power. Now the 3/12 simplifies to 1/4, so it's x to the 1/4, and the y to the 6/12 is what we y to the 1/2. Now when we multiply the numerator and denominator by 2 for the power of y, then we get x to the 1/4, y to the 2/4. So we can write this as x y squared to the 1/4 power. And that is the fourth root of x y squared. So that is the answer. The fourth root of x, y to the second power. And the reason I can take this step, because the denominator in each case for each of the powers of the variables is 1/4. So now I simply reverse the product rule, and I write the product and raise it to the 1/4 power. So for 28, we get, since the index is 6, we get a to the 12th, b to the 3rd, raised to the 1/6 power. So it means a to the 12th times 1/6, b to the 3rd times 1/6. And so 12 divided by 6 is 2, so a squared. And b to the 3 divided by 6 is b to the 1/2. So in other words, that's equal to a squared square root of b. So that's the answer for this, for exercise number 28. Oops. So then the answer for 28 is a squared square root of b. Now number 29 is somewhat similar. That's equal to a to the 5th, b to the 10th, to the 1/5 power. So it'd be a to the 5th times 1/5 times b to the 10th times 1/5. And so a to the 5th times 1/5 is a to the 1st power, or simply a. And b to the 10 divided by 5 is 2, so b squared. So the answer is ab squared for number 29. So ab squared. In number 30, we are supposed to use rational exponents to write a single radical expression for the fourth root of 7 times the square root of 3. So the fourth root of 7 means 7 to the 1/4 power, and the square root of 3 means 3 to the 1/2 power. So when we multiply numerator and denominator for this fraction by 2, then we get 7 to the 1/4 power, 3 to the 2/4 power. So now we can write it as 7 to the 1st power. I'm just going to do that on purpose because this is 1, times 3 to the 2nd, all raised to the 1/4 power. Now 7 to the 1st power, of course, is 7, and 3 squared is 9. So 7 times 9 is 63. So we have 63 to the 1/4 power. Remember this 1/4 here. And that is simply the fourth root of 63. Number 31 is similar. So it's x to the 2/3 times y to the 1/2 times 5 to the 6, z to the 5/6. So 6 is kind of the greatest denominator here. So we need to make everything 6. So we write x to the 2/3 times 2 divided by 2 to get a 6 in the denominator. Y to the 1/2 times 3 divided by 3 to get a 6 in the denominator, times z to the 5/6. This then is equal to x to the 4 6 times y to the 3 6 times z to the 5 6. So there would be x to the 4th, y to the 3rd, and z to the 5th to the 1/6 power. And this expression is equal to the 6th root of x to the 4th, y to the 3rd, z to the 5th. So that would be the answer for this exercise. The 6th root of x to the 4th, y to the 3rd, and z times z to the 5th. So number 32 is a guided solution problem. So a to the 1/2 times b to the 3/8 divided by a to the 1/4, b to the 1/8. So here we subtract the exponents for the same basis. So a to the 1/2 minus 1/4, minus 1/4. B to the 3/8 minus 1/8. So 1/2 minus 1/4 is 1/4. And 3/8 minus 1/8 is 2/8. And 2/8 is the same as 1/4. So then the final answer is the 4th root of AB. So the expression the 14th root of 5m squared means 5m squared divided by 14, and that's equal to 5m to the 1/7 power, or the 7th root of 5m. So that would be the answer for number 33, the 7th root of 5m. Similarly, number 34, this expression means m to the 3rd to the 1/18th power, or m to the 3 divided by 18, and that reduces in the exponent as m to the 6, 1/6, and that is equal to the 6th root of m. So it's equal to 6th root of m. For number 35, this means that we have a to the 5th, b to the 3rd, c to the 24th power, divided by 6, because again the index becomes the denominator, and so that's equal to a to the 5th, b to the 3rd, c, and now the exponent simplifies to 4. 24 divided by 6 is 4. So now we use the product, raising the product to the power. So that's a to the 5th times 4 times b to the 3 times 4 times c to the fourth power. In other words, that then is equal to a to the 20th, b to the 12th, and c to the fourth power. So that's the answer for number 35. Now number 36 looks really a little bit different here, but let's analyze what it means. So we have the fifth root of the square root of x, and we're going to write the square root of x as x to the 1/2. So now we have x to the 1/2 to the 1/5 power. And so now we're raising a power to a power. So we multiply the exponents, and 1/2 times 1/5 is 1/10. So 1/2 times 1/5, and that's equal to x to the 1/10, or the square root of the 10th root of x. So that's equal to the 10th root of x. And this concludes section 6.2.